All right, guys, we've talked about all the properties of equality, and now we're going to use those properties to talk about properties of congruence. So if you look here at the top, you will see these are the properties that you should have seen before, and those are your properties of equality, meaning equal. There, you've got an equal sign in the equation. All right, so, and it even says here, the properties above may only be used if you have an equal sign. The following properties of congruence can be applied to statements with congruent symbol. So the congruent symbol is the equal sign with, well, that's a very bad representation, but it just has a squiggly line over top of it. So it looks like that. All right, so properties of congruence, again, it's just an equal sign with a squiggly line above it. All right, so let's look at a few of these and see how the properties of equality can apply here. All right, so the first one says the reflexive property of congruence. And so we're going to say for any segment AB, okay, remember a line segment is going to have a little line over it to show that that is a line segment. And then we have the congruent symbol for any segment AB. AB is equal to AB because that's the reflexive property. Just like with properties of equality, when you're talking about line segments that are congruent, the line segment would still be congruent to itself. All right, the next property we're going to look at is the symmetric property of congruence. And symmetric property is going to be if you have a segment, let's say AB, and we're going to put the line over it to represent that's a line segment, is congruent to CD. The symmetric property says you just basically you switch the order, so that means CD would be congruent to AB. All right, so that is your symmetric property. All right, the next property is transitive property of congruence. All right, so if we have line segment AB is congruent to CD and CD is congruent to EF, then what does the transitive property say? The transitive property says that AB is also congruent to EF. If both of them are congruent to CD, then that means these also have to be congruent. So line segment AB is congruent to EF. All right, now what is our definition of congruence? All right, so we have segments are congruent if and only if, so this is important, if and only if they have the same measure. So AB, so we're going to say if AB is congruent to CD, then AB equals CD. And if AB equals CD, then line segment AB is congruent to line segment CD. All right, the next definition you definitely need to know is the definition of a midpoint. So the midpoint of a segment divides the segment into two equal or congruent parts. So congruent is the same thing as equal. It's just another word for equal parts. If M is the midpoint of AB, then AM equals MB. M will be in the middle, it's the midpoint, and it's going to split this into two equal parts. All right, the last one that you need to know is the segment addition postulate. So it says if A, B, and C are collinear points, that means they're on one line, and B is between A, C, so B is in the middle of A and C, then that means that AB plus BC, so this segment here plus this segment here is going to equal AC. All right, so that has to be a collinear. That means they have to be on one straight line. Remember, linear equations are lines, and this is just a line segment, but it still applies to the segment addition postulate. So this is the congruence, definitions, and postulates that you need to know. So if you have any questions, let me know.